The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Great. Thank you, Dimitri, and welcome everybody. It's really good to see you all here this fine Sunday afternoon. Fantastic. Good crowd today. Do you have any other videos that I could borrow? Because I love that method, right? Just plug in a video and just watch the responses. That was fantastic. I like that very much. Thank you. I learned something today. So what I'm hoping to get to in this particular next 45, 50 minutes presentation here, Dimitri, he gives me the look. In this next presentation is just to move into a kind of a practical vein to talk about what do we do when we're actually producing SCC in the field and it's going to that perfect project. Oh, Terry left, but it's going to that perfect project. Oh, there he is. What do we do when things change, when things happen in the batches, when things happen in the mix? What do we do? And so what I want to talk about today is just that concept. So this is not about developing mixtures. This is not about a lot of the research work that's done. And we'll talk about laboratory testing, but it's really about how do we take the knowledge that we have from laboratory testing and apply it to production when we're really doing something with the concrete. And so, again, what we'll talk about a little bit is the development process, some of the considerations that we go through, and the wide variety of testing that we can go to. And then from that, some of the things that we've learned, what types of relationships are there between various SCC properties or even results of different practical SCC test methods? How do we link these things together so that we have a good eye when we're in the field looking at production concrete? Then we will take a slight shift and talk a little bit about influence of materials on rheology, but then immediately relate that back to those practical tests for QC testing. And then finally, hey, we're in the field, something's wrong with this particular batch of concrete. What should I do? Right? Has anybody ever been there? Reject it. Typical, right? How about we find a way to save it, right? That's it. So, all right. So we go through the SCC mixture development process, and there's an awful lot that is involved in this process. And one of the things that I would really like to recommend to everybody in here is don't shortchange this process. Right? I think there was a question earlier, hey, should we just take that mixed design and run with it? You can, but it's probably not the best thing to do. At least take a look at it. You know, be practical with it, and don't shortchange it, because there's a lot of things that go into choosing the right SCC. Whether it's the size of the jobs, what are those performance targets, the hardened properties, the fresh properties, that matrix that Terry showed earlier, you know, the element characteristics. How is it being placed? How long is it going to take to place it? Are we dropping it, etc.? All these things determine what I need this SCC mixture to do. Because remember, as self-consolidating concrete, what really makes it different, let's not talk about proportions yet, but what really sets it apart from conventional concrete are those fresh properties that we're looking for. And so we need to keep those things in mind in how they influence or are influenced as we're developing the mixtures in the lab. So then again, we consider all these things, we go into the lab, we have the materials that we can use for the project, and we develop some mixtures. Maybe we develop a couple of mixtures, run it through a wide variety of different tests. And the different tests that we typically do, and this is, I just threw a bunch of them on here, and I do have the L box too, but that's okay. But these are just good ways to evaluate the mixture for what it's going to be able to do. How far does it flow? How fast does it move? Because here's the thing to consider. I should certainly match up how fast that SCC mixture moves through my form with how rapidly I place it. Right? Because it's going to fill up the forms in different speeds, and you need to consider that. the visual stability index or other stability tests. These are all important things that as we're developing SCC in the lab, running through different materials, that we understand the fluidity behavior, the stability behavior, the passing ability behavior, regardless of which test you use. Choose whichever ones you like, but make sure that they're defining the performance parameters that you need for your project. That's the important thing. Now, as we go through all this testing in the lab, we should always have at least half an eye looking towards what we're going to do in the field. How are we going to control it as we produce it? We shouldn't just be doing testing, and then we've got all these numbers, and then we just push that off to the side because we have a mix. Run it. Those tests that we run in the lab should have some link in our minds to what how we're going to control performance in the field, on the job site, out of the batch plant. And so as we're doing that, we should think through, okay, it's usually not very easy to test stability in the field, so I'm going to focus on that today. So how do we make sure that we've got the right parameters set so that we ensure that we have a stable mixture in the field through our testing? Well, some of the things that we know is that as we take a given SCC mixture, a set of mixture proportions and a set of materials, there is a distinct relationship between that mixture and those materials, between the slump flow amount and its stability. The higher I go in fluidity, the more care I need to take to ensure that the mixture stays stable. And all I did was just pull out two mixtures here that we adjusted simply with high-range water reducer, the exact same batch of concrete. And we did our column segregation test, and we went from a 23 to a 26 to a 29-inch slump flow, and we saw the segregation for those two different mixtures. Now, the other important point here is, what should the slump flow range be for quality control testing for this mix versus this mix? If our maximum is 10% segregation, I could have a 23 to 29-inch spread just to control stability. I'm not saying that we'd want that for placing in a wall, but for this mixture, I can't have that wide of a range. So the way that we set specification should not just be to randomly say, plus or minus 1.5 inches. That's good. It should be based on what the mixture can do. And what we're seeing here is that they can do different things. We also know that as the viscosity of a mixture increases, generally speaking, we tend to improve the overall segregation resistance or stability of a mixture. So we have these two things in mind. Mixture gets more fluid, it gets less stable, mixture gets stickier, more viscous, it becomes more stable. In general, those are general trends. And again, remember, I'm talking about trends from the practical perspective of how we control things in the field. We also know that our T50 time, in general, matches with our viscosity. So now, I've got the idea that, right, slump flow and T50 those two things together can give me some insight on site or at the batch plant to the overall stability of a mixture. They can start to paint me put me in the right ballpark. Again, I already have a mixture developed. Right? I keep wanting to state this. I'm not developing mixtures now. I have one developed. As slump flow or T50 shift, my stability shifts with them for a given mixture. Right? So for a given mixture, as slump flow increases, T50 decreases, mixture tends to move towards a more unstable mix. Now, I've done all this testing. I understand some of these relationships. What we suggest to our customers to do is just go through a process of some very simple robustness testing. I just mentioned earlier that we had the same batch of concrete and we added more and more high range to it and changed the slump flow levels. Well, as we hit those different levels of slump flow, we can do a variety of other tests at those different points and start linking together what may happen in the field if slump flows go up or down. We can also do it with water, just in case moistures aren't exact for those batches, batch to batch to batch. That might happen sometimes, okay? So we go through this process, and so once we've developed the mix, we tend to, and we've done our mock-ups, we tend to have a target space for our slump flow, and let's pretend it's in this box here. And we tend to have a target space for our T50 for this, slump flow and viscosity thing to, again, to control stability. Now, we do all these other tests, and we start to paint a picture that we can give to our batch people. We start to paint a picture that we can give to people in the field that says, okay, this is my target. Now I'm falling into a different space. What happens if my results are down here? I should know before I go into the field whether or not it's going to be highly segregated or not. I should know these things before I go to the field, because this is how I start to determine my way of making adjustments, right? If all of a sudden I'm out in this area here, and we'll actually get to in a minute, and my mixture is falling apart, whether I've got a VSI of 3 or whatever it is, I need to be able to do something with that. But when we're in the field, right, how do we determine that? And it's going to be by ensuring that we make the right measurements and not just a single slump flow measurement. And I want to take a moment to actually talk about that, because what I have seen too many times is that we as an industry, we want to treat SCC similar to the way that we treat conventional slump concrete in terms of our fresh property measurements in the field. I just want the one test. Just tell me what my slump flow number was. I'm good. This is not conventional slump concrete. We're not just measuring slump. It's actually a good thing that we can measure some other thing that gives us an indication of the viscosity. That's actually a good thing for us. Now we have the opportunity to be more direct and have the opportunity to make better adjustments. So in the field, we need to be doing more measurements. The other thing I want to suggest to you, and I hope that you'll see how all these different things come together here at the end, so you bear with me. When I'm in the laboratory and I'm making different adjustments, now go figure, here's an admixture guy telling you that not all polycarboxylate high ranges give you the same performance. They don't. I don't know how many I just really want to make sure that everybody gets that. They don't all perform the same. And so what this shows you here is my dosage based on the amount of slump flow that I get for 3 different polycarboxylate high ranges. Now, I should know this, because I'm going to want to make adjustments to my SCC mixture if I'm not hitting the right slump flow. I should know whether or not a slight change in polycarboxylate 2 here is going to give me another 75 millimeters of slump flow rather than 20. I really want to know that. So talk to your admixture supplier, because they know. Make sure, because you don't want to just assume, now it's per 100 weight, that'll give me 50 millimeters for everything. That's setting yourself up for problems. So we've seen some of these things from Oliver, where different materials influence viscosity, whether it's addition of water from a reference point. We see that yield goes down, plastic viscosity goes down. What I'm trying to do here is actually link these material behaviors to our practical tests that we'll be doing in the field, which is T50 time and slump flow. So in general, all this is saying from a general perspective is, if I have a reference SCC mixture, and if my water content goes up, my T50 time is going to get faster and my slump flow is going to get higher. Pretty straightforward. If I add superplasticizer to that same mixture, my slump flow is going to get higher, but my T50 time will probably stay in the same range. This is important now. Consider that you're out in the field and you're getting slump flow and T50 measurements. Remember this thing that we showed earlier. Now, if I start getting results in some of these different spots, okay, the mixture down here is flowing faster and it's flowing too far. What could make that happen is what the batch person or the person in the field should ask themselves. Is it too much water? Is my mixture design off? Because remember, we're batching the same mixture time and time again. I would suggest to you that we can go to something like this. If this is my target area, and I have it well defined, and my slump flow, let's say in my T50, is on target, I'm right in here, and my slump flow is short, if I had high, remember, high range is not going to change my T50. If I add high range water reducer, it'll move me in this direction and get me back in the box. Now, if my slump flow is too high and my T50 is too low, I would suggest that that's probably too much water, and you better check your moistures. Because if I pull water out of a mixture down here, my T50 is going to get slower and my slump flow is going to get shorter. So this type of box can be created to guide the practitioner as you're batching concrete, as you're measuring batch to batch, and as you're measuring it out in the field. This is a way for us to gain control over SCC production. But it links all the way back to our mixture development process, right? I only know how much high range to add if I know how much high range to add, right? I have to have at least done it and know which high range that I'm using. The other thing to consider is that if we're using mixtures that are developed to be very robust, what does robust mean? It means that they're not as susceptible to water fluctuations. So if I'm adding water to a very robust mixture, what will likely happen to the amounts that I would have to use relative to other ones, especially some that contain high levels of viscosity modifying admixtures. So we have to know these adjustments are very much tied directly to the mixture proportions and the admixtures and the materials that we've developed for a project. And so this is the type of process that we can go through. So in general, in conclusion, during the mixture development process, during that process, we need to be thinking about our quality control plan and developing it. And we can put together, again, guidelines for our batch people to make adjustments. And those adjustments, though, remember, I showed you that if all I was getting was the slump flow measurement, I wouldn't be able to make an adjustment. I would be guessing. But SCC allows us the opportunity to measure all those things. And again, water or admixture additions are dependent on materials and the admixtures that you're using. Thank you.
Thank you, Joe. Got time for a question?
Very interesting presentation, Joe. My question to you, and I was going to ask this to Terry if he had the time to, is that we have these specifications and we have these requirements, and they are always tested within the first 10 minutes in the beginning of the job. But these jobs take 60 minutes, 90 minutes, sometimes 2 hours. So how do you, what do you do for that? How do you address this issue?
Well, I mean, you're talking about the time-dependent behavior of an SCC mixture.
What do you do about that? In the spec, or where do you get these things into the picture?
Well, what we always suggest to our customers is that we suggest that there's a very clear conversation held with the contractor, which relates to placement techniques, placement time. How long is it going to take? How long is it going to take? What's the transportation time, plus the amount of time to place it, plus the amount of time that concrete's going to be sitting in the form waiting for another load to come on top of it to mix with it. Because it still needs to be a high slump flow until that next load comes on top of it, or else you'll get the joints. So you need to have that discussion and say that this concrete needs to last for this long or this long, and then it needs to be developed appropriately. Yeah, absolutely. It's just communication. Because those things can be taken care of. Not just through admixtures, although admixtures help, right? But they can be taken care of through proportioning, etc. Right. So the time-dependent behavior is very important.
All right, Joe. Thank you very much.
Thank you.